I am going to be talking about the future of PostgreSQL. The first thing to say is exactly how far we've come so far. So the topics that I'd like to talk about is how well adopted PostgreSQL is, how many users we have. But then the rest of the talk is mostly about technical topics, which I think is possibly the most interesting thing for people here. So the first thing to say is that Postgres is now in use all over the world. It's not an American piece of software, it's not a European piece of software, it's in use all over the world. And as we've just seen, it's being written by people from all over the world. Okay, so it's not just a single small group of people doing this. There's a large group of people all across the world. We've got some major milestones. Apple use Postgres now on their OS X servers. Heroku and Salesforce have got 1.5 million servers on the cloud in use. Okay, so these figures mean that we have documented use of almost 2 million servers around the world in terms of the number of big companies that use it and the number of devices it's installed on. Okay, so we don't talk about 10,000 downloads anymore, we're talking about millions of active users. The last thing I've put up there is some comments today from Amazon. You heard some discussion earlier that Amazon RDS now runs Postgres, okay? So that's good news. What's better news is what he said about Postgres. Werner Vogels, the CTO of Amazon, said Postgres is an amazing database. Now, when he put MySQL into RDS, he didn't say MySQL was an amazing database, but he said Postgres was an amazing database, okay? So I think that alone is worth a round of applause, yeah? he could have said some other word other than amazing, couldn't he? Yeah, he could have said, no, okay, yeah, it'll do, yeah, but he didn't. He said amazing, all right? So that's important. He then said Postgres has become the preferred open source relational database for many enterprise developers, okay? So if the guy at Amazon is telling the whole world that it is the preferred database, then not only do we think that is true, but also it's going to have an effect on all the people that were not watching what was happening, okay? So this is a very important statement. Now, I've only got one thing to correct him on, and that is the word open source, the phrase open source, because he said it was the preferred open source relational database. And the problem there is that really what I want him to say is just simply preferred database, okay? So we have still some way to go before we've got to the place that we're headed for. So what does the future look like? Well, perhaps we'll have Google, perhaps Oracle, maybe Microsoft, okay? Intel, and hopefully Gucci. So we have wearable databases.
Well, actually, I have news from Intel. They are implementing something in Postgres here in Argentina, in Córdoba. Okay. And they are using some clusters. They were using MySQL and some kind of Postgres.
Yeah.
But it's an internal project. We don't have any specification about that.
So there are many companies already using Postgres, and I can tell you at least 2 of the companies on that list already use Postgres, okay? And it's not Gucci. So what I'd like to do now is talk about the technology of Postgres and where we're headed with that. Okay, clearly the world is coming to understand that Postgres is a good database, but what I'm going to tell you about is how it's going to get even better. So at the moment, as Alvaro has explained, we're working on a number of features. The current development release is 9.4, and already in this release we have some interesting performance features. We have while insert concurrency, which will allow the write rate into the database to increase by somewhere between 20 and 50%. And that will make an interesting contribution to performance. There's also been a discovery that multi-core performance can be improved substantially, and we've got patches that allow 400% improvement on a 4-core system for the heavy transactional workloads. So the high-end performance of Postgres is going to increase substantially in this release.
¿Alguna duda por ahora? Vale. No, continue, please. Sorry.
So the current work in progress is obviously many different things. There are more than 70 patches on the queue at the moment, so I have just picked 5 areas to talk about a small amount. First is re-index concurrently. If you're already a Postgres user, this could be an important thing for you. The second one is alter table. Currently it locks the whole table while it executes, and it looks like we're going to have a feature that will reduce the lock level for alter table. So for example, you can add a foreign key while still running selects against the table. Some bigger features that I regard as strategic are row level security. This of course is for the NSA. That was supposed to be a joke, but they probably are using it. So
I already made that joke.
Okay, I'm sorry. The next one is min-max indexes, which we've had explained in considerable detail. And the last one of those is logical replication. So I'm going to go into that in a little bit more detail. So Alvaro described the min-max indexes. What I wanted to do was just go through the benefits of min-max indexes so that we can see things maybe from my perspective. So this is not how they work, this is just why they are good. So the first one is it does not require complex DDL. Min-max indexes are in some ways similar to partitioning, but instead of writing lots of code to chop a table up into pieces, you just add an index. So it's one statement rather than many statements, and the manual work involved is very little. Min-max indexes generate almost no index inserts, which means data loading into a table with a min-max index will go very fast. Current B-tree indexes slow down as the table gets bigger. A min-max index doesn't slow down as the table gets bigger. So this is a very important property that it will allow us to have much larger tables with a higher insert speed. And the last one is that the inserts into the table generate almost no transaction log overhead, which means if you run a copy of that using hot standby, then the overhead for maintaining that copy will be much lower as well. So that allows you to have multiple copies of the database for read access. So I'm very excited about min-max indexes, and very pleased that we've been able to do that in the way that we've done it. What I'd like to talk about now is logical replication, which is another feature that Second Quadrant is developing. The main developer on that is somebody called Andres Friund, and but not just that, we've got quite a range of different people involved in that project, and as of now it's taken 2 years to get us to this point. So what is logical replication? Well, what we currently have is called streaming replication, and I call that physical replication. I call it physical because what we're doing is we take a copy of all of the data blocks. It's an exact copy at the data block level, okay? So we're not doing anything at all to the data blocks, we're just taking a copy. Now that's easy and it's simple, and it's why we've managed to get it to work so far. Logical replication is where we, instead of taking a copy of the data blocks, we take a copy of the data and just move the data. Now when we do that, it opens up many different opportunities for us. But one of the things that we need to do there is we need to support DDL changes, because the physical copies allow us to handle DDL easily, whereas logical replication would become more complex. So how does this work? Well, in physical replication, it involves reading the... Has this got a laser? No.
What do you need?
Okay, don't worry. So the WAL is the transaction log, and this gets copied to the WAL sender, across to the WAL receiver, and then down onto disk again. So this is how physical streaming replication works. We have two processes talking together to do the replication. So logical replication works almost the same way. It uses the same concepts, the same parameters. What we have though is that the blue box here is... Okay, thank you. The blue box here allows us to write a plugin where we can translate the transaction log. So if you're familiar with Oracle, where Oracle allows you to have something called log miner, and it allows you to read the transaction log and do something with the data. This is exactly the same facility we have with Postgres. So we can write a plugin which translates the transaction log, and here we translate it into a stream of data that allows us to replay the changes on this database here. So in this situation, we have a master where we do the writes, master, and here this is a standby. We're not allowed to do writes on this node. So it's read and write and read only. In this situation, both of these databases are masters. So we can write on either. In this example here, changes on this one are sent to this node.
So it can be bidirectional also.
Right. So this diagram shows the flow in one direction only. It is easily possible, as you say, to have a flow in both directions. But when the flow goes in both directions, you would have two lots of processes. So there are two pipes, one for each direction. there's a new device here called a slot that remembers where the downstream master had got to. So when it reconnects,
They both can write to the center.
Yeah, wait. So
You don't want to have the same problem as MySQL, please.
yeah. So let me keep it simple. First of all, I describe one-way replication, and then we talk about two-way. Yeah, two-way is much harder. Okay, so so the same idea, the same pattern of how it works is the same between logical and physical replication. What we're doing is we're reading the transaction log here and we're applying the changes. Now we've designed this to be very efficient because using the transaction log rather than using triggers makes the overhead on the master much lower. So in comparison to Sloaney or Londeast, this is between 4 and 8 times faster overall. That's because we reduce the load here and we reduce the load here. So when we apply the changes, this is not SQL we're executing, we're making the changes at a low level by direct injection into the database. Okay, so very efficient. So what we hope is possible is that once we've managed to get one-way logical replication to work, we can get multi-way replication to work. And not just for 2, but you see here I have an example of 5 databases working together. Now currently we've tested this with 19. So 19 different servers working together. Now the cool thing about this is that physical and logical work at the same time. So here we have one master which is protected by 2 standbys. So this is a cluster, this is a cluster, this is a cluster, this is a cluster. So by using this technology, we're able to build a geographically distributed database where each group of nodes is protected. And I can already tell you that McAfee has a system like this planned, and many other people as well, because this is exactly what larger companies need when they have a worldwide application.
¿Alguna duda por ahora?
This scenario, what happens you have at the end of the commit, you have to wait till the majority of nodes are updated to send out to answer the commit?
This is a different issue. So this is really what I'm describing as a transport problem. What you're talking about is an acknowledgement problem. This is a different thing, and we can build acknowledgement systems on it, so we can protect it with synchronous as well. The initial version is asynchronous, but it is easy to add synchronous and also easy to add voting systems, quorums, yeah.
It's like a quorum in Cassandra,
Yeah.
basically, what you're thinking.
It can be, it isn't yet.
But it's not the same actually. Yeah.
So what's interesting about this diagram is that I've drawn it like these were servers, okay? The important thing about logical replication is it allows transfer between different CPU types. So there's no reason why all these devices, iPhones, your mobile phones, could not have data replicating back to a central server. So while I've drawn servers talking to servers, there's no reason why we can't have small devices talking to bigger servers. Yeah? So what we're hoping for in terms of adoption in the future is that every device manufacturer includes a Postgres client and Postgres database and logical replication facilities. So every time you write an iPhone app, you can write it with a database in mind, and you can just make it replicate to a server somewhere. Okay? And that's going to be pretty cool, I think.
Yeah, it should.
So how is this happening? Well, we're not building such a large facility in a short period of time. It's taken 2 years already. About half of the work is already included in 9.4. But what we're aiming to do is only include the send portion. The receive portion is going to be in the next release. And the bidirectional or multi-master is the one after this. Okay? So what we're hoping to do is get enough software together so that this release can send data to the following release. And when we do this, it will allow us to do online upgrade. Okay? So as soon as we can do online upgrade, it allows us to do many other things like change the disk format as many times as we want, really, because we're going to be sending it to a different server. And so the idea here is one of the first things that we're doing is building in the capability for online upgrade. Okay? Now, obviously, because we need both send and receive, we can't upgrade from 9.3 to 9.4. We can only upgrade from 9.4 to something in the future.
That was really awesome.
Okay? But we're getting there. So I've suggested that we call the next release 10.0, but that is not accepted yet. So how will this work? Well, in this release, we've got all of the code, but it's going to be available as extensions. So some portions of the code are outside main Postgres. So it will be a project that looks a bit like Sloaney. Okay? But what we're planning to do is fold it into the main core of Postgres so that all of these facilities are available in core. So where are we with this? Well, the main piece of work is what's called change set extraction, and that's the translation of the transaction log. That is being managed by Andres, and although I've listed some other things, that is by far the largest piece of work. Okay. Then Alvaro is working on event triggers and something called a commit timestamp, and I'm working on what's known as the sequence access method. This is something that will allow sequences to work across a cluster rather than just on the local node. Okay. So the way that we're approaching the design of this is in the normal Postgres way. We want it to just work. We want it to be robust and of course very well designed. So these things take time. So as you'll see from the plan, we've been working on it 2 years already. We'll be working on it for 2 more years yet. Okay, and of course that 2 will soon become 10. So the roadmap I have for new feature development is, I hope you can read some of these things. Logical replication has already been going on for some time and will continue into the future. Row-level security has already been in progress and will continue for some time. What Alvaro talked about was the Axial project, which is about advanced business intelligence. But there's also other pieces of work ongoing with regards to handling very large databases and globally distributed databases. What does that mean? What it means is everything you can already do in MongoDB will be available as a feature in Postgres in the next 2 years. So anything you can currently do with that will be in. Anything you can currently do with Redis, CouchDB, all of those things will all be in Postgres as options. Okay, that doesn't mean we're getting rid of SQL. What I'm talking about is offering options to users, because the direction that I see things taking is that Postgres is a very pluggable system. We have pluggable functions, we have pluggable data types, and what we're adding in this release is pluggable sequences, but many of the aspects of Postgres are pluggable. And what this gives us is what I'd call a rich data platform. It allows us to assemble a data processing framework. So it's not just a database in the old sense. This is like an operating system for data. Okay? And just as the way that Linux is an operating system and we add new things to that operating system, what I would like to see is where people, instead of inventing a new database, they say, how can I implement that feature on top of Postgres? Because that way we have more people involved and everybody is happy. Every time somebody starts from the very beginning again, then they're wasting time, wasting development effort that could be going into a single good system for people to use. So that's my take on where we're going with Postgres. Just a little bit about second quadrant. As you can see, we're actively extending Postgres. We are the only company at present providing 24/7 support in Spanish. Okay, and I'm extremely proud of that. I'm proud to be here in front of you to say that, and that's really because of our commitment to the Spanish-speaking community that's been possible. So, assuming you're going to use RDS or Heroku or any of those other fine providers of Postgres, you might persuade some of the people that you work with to buy support from us. So, I hope that's possible. So, if you'll excuse the small advert. Does anybody have any questions about the roadmap?
Behind the global distributed.
That would include things like auto-sharding, the ability for multiple nodes to work together on...
Global transaction ID, basically.
Not necessarily, but that's possible. But certainly clusters of databases working together.
Not a single database, but multiple databases connected.
Yeah. So at the moment we have individual databases connected by replication. In the future we will have workloads that spread out across multiple nodes automatically.
Is that a well-known situation, or are you already working on this?
Well, as you see, it starts here. So, no, we aren't already working on it, but we have plans. It's the logical step after logical replication. So.
Question, can you put dates to that?
No. Next. I've put releases. That's as granular as it gets. So. Any other questions?
How are you feeling the development community? Do you think that it's taking more strength over time, or have you been losing some core developers? What is the short history?
Well, what I can tell you from my knowledge is that I mean, certainly the number of people in second quadrant's grown, so that means there's been an upsurge in development. I guess there's been a few people that have disappeared, but I think it's going upwards, the amount of development. It's been steadily going upwards. It's not leaping upwards, it's not double what it was, but I'd say it's going up at 10 or 20% a year, every year. We're certainly doing more now than we did in the past. So.
There is a graph about that, about the number of committers and developers.
Yeah.
And so you can find it.
I can say that hay muchas empresas que han tratado de contratar desarrolladores de Postgres y no han encontrado puestos tanto y crece, digamos, todo el tiempo se incorpora y una vez que son suficientemente capaces no hay que contratar. Todos, digamos, siguen participando en la comunidad de desarrollo global.
¿Podrás hacerte una pregunta por mí? Bueno, estaba hablando de las bases de datos distribuidas globalmente. No llegué a escuchar bien qué tipo de club pensaban hacer al respecto. La pregunta concreta es el tema de los joins, las transacciones, si quieren salir en el modo SQL, la parte distribuida.
He's asking if when you think about the globally distributed database, you are thinking about the load balancing queries and showing data between nodes. If you are thinking about that, or it's just only a transaction level.
Well, it's that whole area of thought. Which order we develop things in is yet to be determined. But what I'm saying is, it's a line of thinking that will begin once we've got the transport mechanisms in place for data, then we can start thinking at the next higher level of thought. Yeah. So.
¿Lo pensabas en la parte de balanceo o lo pensabas en la parte de distribución?
En la parte de distribución.
Oh.
Paralelización.
It's parallel queries. Well, actually,
I understood. Yes. Yeah.
There is something about Robert Haas. He's working on parallelism.
Yeah, but I'm talking
it's not about the global
multi-node parallelism, or some people would call it massively parallel, but I'm talking about workload migration and similar things. But I include within that clever use of foreign table wrappers and such things.
Okay.
So.
How do you see the competition of the open source database? I'm not talking about non-SQL. Some new people also on SQL. Do you see a growth there? Do you see something happening? Or?
No, not really. They have a problem. If you have a very simple database, once you've written it, if you tell everybody your feature is that it has no features, then once it's done, you can't improve it, because then if you're saying having no features was a feature, then you can't add anything more to it.
I was thinking about new full SQL implementation is 2 years.
Yeah, I mean, there's a lot of good people in the world with great ideas, and I would be very pleased for them to come to work on Postgres, but that doesn't mean that everything I see is a good idea. So, so here is when I learned Spanish. Okay.
Cool in the roadmap. Yeah.
Yeah.
Why not? And very large database seems like you start between the 9.4, so maybe there are some ideas about what you're thinking to do. Or
Well, we already did some work here.
It's related
as
with
part
the
of
change.
the Axial project. So this, and this are part of the Axial project.
Okay, that's why are between the 9.4 and 10
Yeah.
version. Okay.
So one of the things that we initiated work on was a way of getting vacuum freeze to not be needed. So we think that we've got some ways of avoiding wraparound vacuums, for example. Okay. Now they get to be really annoying when you have a very large database. Okay. So that's one of the things that we're doing. But this here is basically it's not so much a feature as a removal of obstacles out of the way. So as databases get bigger, we'll work out why there's problems and remove them. But the Axial project is aiming to support databases that are 100 terabytes in size.
That's cool.
Okay. Any other questions or thoughts?
You mentioned one of the features of 9.4 was you're going to increase write performance or insert performance.
Yes.
Could you elaborate a bit more on the technical side of that?
Can you repeat the question?
It was about how does the WAL insert performance increase work. So the way it currently works in 9.3 is that in order to insert into the transaction log, you need to hold a lightweight lock called the WAL insert lock. You get the lock, and then you insert something into memory, do some activities, copy the data in, and then release the lock. So while that is happening, nobody else can insert into the transaction log. So what we did, I think it must be about 5 years ago, is work out a way of splitting that into two portions. So the first half is where you request space in the transaction log, and then the second portion is where you copy the data into the transaction log buffer. So by splitting it into two, now the first part where you reserve space is much quicker. Okay, once you have the space reserved, then you can copy the data in. But the trick here is that multiple people can copy in at the same time. Okay, so whereas before only one person at a time could do it, now we have multiple people can stream data in. I think it's 8 people at a time in, and this greatly increases performance when you were doing a very high write rate. So I think the current maximum Postgres performance was something like 12,000 write transactions per second, and we're going to be coming up towards 20,000.
Oh, nice jump.
So, is there some consideration to take when you use solid state devices? Is something to change? Is there something to change in Postgres regarding the massive?
Not really, no.
Solid state devices?
They're kind of easier to manage as long as you use RAID. Don't forget RAID. Any other questions? Okay. We done? Perfect. Thank you very much.
Awesome.